Engineering Department, D.Y. Patel College of Engineering, Nagpur. Today here we are discuss circular convolution and difference between linear convolution and circular convolution. So first of all we will start with the circular convolution, a shortcut method, that is matrix multiplication method. So for solving, we will take one example. x1 of n is equals to 1, 2, 3, 1 and x2 of n is 1, 2, 1. For solving the circular convolution, we want the length of x1 signal and x2 signal must be same. So the maximum length of any one of the signal is the length of circular convolution. So from these two, the length of maximum length is 4. So that's why the output length will be 4. For solving, we will take matrix x1 0, x1 1, x1 2, x1 3, then x1 0, x1 1, x1 2, x1 3, again x1 of 0, x1 of 1, x1 of 2, x1 of 3 and x1 of 0, x1 of 1, x1 of 2, x1 of 3. This is the first signal. Second signal is x2 of 0, x2 of 1, x2 of 2, x2 of 3. And then we get the output as x3 of 0, x3 of 1, x3 of 2 and x3 of 3. Means by putting the values in this matrix form, we will get the answer of circular convolution. Only the constraint here is that the length of x1 signal is 4, length of x2 of n signal is 3. So we have to add 1 0 in the length in the x2 of n signal. So x2 of n signal will be 1 2 1 0 for solving the circular convolution. Now simply we will put the values of these x1 and x2 signal. We will put the values x1 of n and x2 of n in this matrix format. For example, x1 of 0, the value of x1 of 0 is 1. It is the value of x1 of 0, x1 of 1, x1 of 2, x1 of 3. So x1 of 0 is 1, x1 of 1 is 2, x1 of 2 is 3 and x1 of 3 is 1. Again by putting the x1 0, 1, 2, 3 means it is 1, 2, 3 and this is 1. Start from this point, it is x1 of 1, 2, 3, 1 and from start last point, that is 1, 2, 3 and it is 1. Now these are the values of x1 signal. Put the values of x2 signal here. x2 of 0 is 1, x2 of 1 is 2, x2 of 2 is 1 and x3 of 2 is 0. So just by putting the values 1, 2, 1, 0 and by solving this using matrix multiplication, we will get this value x3 of 0, 1, 2, 3. So for x3 of 0, for matrix multiplication, multiply this row with this column. That is 1 into 1 is 1 plus second term 3 into 2 is 6 plus 2. Second term 1 into 2 is 2 plus third term 3 into 1 is 3 plus 2 into 0 is 0. matrix multiplication of second row with this column. So by calculating, we will get the x3 of 1 as 5, x3 of 2 as 8 and x3 of 3 as 9. So 6, 5, 8, 9 is the answer for circular convolution. The basic difference between circular convolution and linear convolution is its length. So after solving this example, we come to know that the length of circular convoluted signal is 4, x1 of n, circular convol with x2 of n, then we will get the length as 4. Because we obtain the length of circular convolution as the maximum length present in the sequence. So maximum x1 and maximum x2. From x1 signal and x2 signal, whatever the maximum, that will be the length of circular convolution. But for the linear convolution, the length is calculated as L equals to m plus n minus 1. So m means the length of x1 signal, that is 4. N is the length of x2 signal, that is 3 minus 1, that is 6. So after solving the same example, for the linear convolution, length will be 6, means we will get the 6 element for the linear convolution signal, and for the circular convolution we will get this length as 4. This is the basic difference between circular convolution and linear convolution.